been having some questions about the drag race type problems. So I thought maybe I ought to do the one that's in the book, and then maybe you can figure out the one that's on the homework. This is number 17, page 5, and it's supposed to be a hard problem because it's the very last one in the section. So we have Allison and Kevin. They're in a drag race, beginning from a standing start. Okay, that means their initial speed, their initial velocity is 0. And their initial position is 0, since they're starting at the same place, I assume. They each proceed with a constant acceleration. Then we know that something about how Allison does in the last part of the race. She covers the last 1/4 of the distance in 3 seconds. Kevin does the last 1/3 in 4 seconds. Who wins and by how much? Okay, so it's not a constant speed. So we can't. It's not an easy question. Let's recall something from calculus, though. Back in calculus 1, we had this. We're letting S be the position. We're moving along some sort of number line, and S is the position in time t. The derivative of S is the velocity. It's a function of time as well. And the derivative of velocity is the acceleration. And it's a function of time as well. So we're going to set things up from Allison's point of view. We know that she has a constant acceleration. So let's let A be Allison's constant acceleration. Okay. Now we're going to work our way backwards by taking antiderivatives. Okay. So her velocity is the antiderivative of A dt. It's a d there. So it's going to be AT and plus 0 because she starts from a standing start, so the initial velocity is 0. Okay. And her initial position, is the antiderivative of velocity, which is the antiderivative of AT dt. T is the variable here, so this is 1/2 AT squared, and the starting gate is the initial position 0. Okay, we're moving in one direction. Velocity is not changing direction or anything. So this is not only the position at time t, this is the distance covered. In t seconds. Let me rewrite that. So our distance that we travel is 1/2 the acceleration time the square of the time that we travel. Okay, let's solve this for t. If we multiply by 2 and divide by a, we're left with t squared. If we take the square root of that, so 2 over as, the square root of that is t. So if you know the length, the distance, the length of the drag strip, we know her acceleration, we can figure out how long it took her to go this way. Okay, so this is the time Allison takes. Okay, so let's kind of rewrite that a little bit. So t equals Allison's time. Okay, it's also, we'll break this up into 2 pieces. We've got the first 3/4 time plus the last 1/4 time. See, they give us the last 1/4 time. Well, this part's easy because the last 1/4 is 3 seconds. Okay. Now, looking at this expression, though, trying to figure out this. Okay. We're doing the first 3/4 of the track. Okay, so this is my expression for time here. So it's 2 over a, the square root of that times. Well, what distance are you covering? You're not covering the whole distance, you're covering 3/4 of the distance. Okay, let me see if I can scoot this over some. Okay. Allison's time is the square root of 2 over a times s. Okay. And if we're only doing 3/4 of the track here, this is the thing, then it's 2 over a times 3/4 of s. Actually, this is kind of curious here. The time Allison takes is, what is this thing? This is 2 over a times s times 3/4 plus 3. But wait a minute, what did we already say this was? We said up here that Allison's time was this. So let's plug that in. In other words, the time it takes her is the time it takes on the first 3/4. Okay, this much is t. Now we still have a 3/4 that's under the radical, because the 2 over as under the radical was t, and then plus 3. Well, this is a real simple equation. It's just a linear equation. T equals square root of 3/4 times t, and the 3/4 is entirely under the radical. I can do better than that. Okay. I solved this on my calculator since I'm only interested in decimal approximations, not the exact answer. And I solved it somewhere here. Hold on, I'm going to have to pause. So when you find a decimal approximation to this, use the math solver, you get that the time, whoops, let's go here. Allison's time is approximately 22.39 seconds. Okay. Okay, that wasn't too bad. Now, if you're doing Kevin's, I'm not going to go through all of Kevin's here, but let's change to a different color here. Let's do green. Kevin is going to be green. Okay. What you would do is you would put in some other constant here for Kevin. Okay. And you would get, down here, you'd get Kevin's time would be Kevin time. Okay. When you got to this particular spot, you'd have Kevin's is 2 over k times, well now Kevin only, his thing is divided up into thirds. So it would be the first 2/3 s plus, well he does the last 1/3 in 4 seconds. Okay. And to get down here, you'd end up for Kevin. Kevin's total time would be this times the square root of 2/3 plus 4. Again, this is a very simple equation here to solve. And when you solve that, I'm going to do it on the calculator. You would get that Kevin's time is approximately 21.80. Okay, so Kevin's time is less. he wins by about 59 hundredths of a second. Okay. So it really isn't that hard of a problem. You look at this, it's the key step is when you write this expression, when you recognize that it is something times the full time there. Okay, so hope that helps.